Welcome to solverfy.
Okay, so in this problem, we have to find out two things. First, we have to calculate the theoretical yield of C2H5Cl that was produced in the reaction of C2H6 and Cl2 or chlorine gas. And then we have to find out the percent yield of C2H5Cl if the reaction produces 206 gram of C2H5Cl. So our first step will be we'll have to write down the reaction equation, and from there we will have to find out how many moles of C2H6 is reacting with how many moles of chlorine to produce how many moles of C2H5Cl. And from there, since we are given the mass of C2H6 and Cl2 reacting, from these two mass we can find out the number of moles of C2H6 and Cl2 reacting, and from that we can find out the number of moles of C2H5Cl being produced, from where we can find out the mass of C2H5Cl produced. So let's start writing down the reaction equation here. So the reaction is between C2H6 and Cl2, which will give us C2H5Cl plus HCl. Now, so first we have to make sure that if the reaction is balanced, because if the reaction is not balanced, we will not be able to know how many moles of which reactant is reacting with how many moles of the other, and how many moles of the product is being produced here. Okay, so from here we can just see that the reaction is balanced with our BRIs, because we have two carbon here, two carbon here. We have six hydrogen in the reactant side. We have 5 plus 1, 6 hydrogen, and we have 2 chlorine in the reactant side and 2 chlorine in the product. So the reaction equation is balanced. That means 1 mole of C2H6 will react with 1 mole of chlorine gas to produce 1 mole of C2H5Cl and 1 mole of HCl. Now, since we have to find out the mass of this product here, first you have to know how many moles of C2H6 is reacting with how many moles of Cl2, and we can find out that from the mass of these two given in our um, in the question. So in the question we are given that the mass of C2H6 reacting is 125 gram. That means we can find out the number of moles of C2H6, which is its mass over the molar mass. So the mass of C2H6 reacting here is 125 gram, and the molar mass of C2H6 is 30.07 gram, which is simply the molar mass or sum of the molar mass of carbon and hydrogen. So since we have two carbon, it will be so carbon's molar mass is 12, so 2 times 12 is 24, and hydrogen's molar mass is 1.08, so 6 hydrogen will give us 6 point something, and the sum will give us 30.07 gram. Now this will give us a value of 4.16 mole. So this is the number of mole of C2H6 reacting here, and then we have to find out the number of mole of chlorine gas which is reacting. So the mass of chlorine gas reacting here is 255 gram, and the molar mass of chlorine is 70.906 gram. This will give us a value of 3.60 mole. So this is the number of mole of chlorine reacting. So if we just put these values here, that means 4.16 1 6 mole C2H6 is reacting with 3.60 mole chlorine. And since from here we can see that 1 mole of each reactant will react to produce 1 mole of the product, that means from here we have to find out the limiting reagent, and the the number of mole of the limiting reagent will be the number of mole of C2H5Cl being produced here. So from here we can easily see that since 1 mole of each reactant will react, and so in this case the limiting reagent is chlorine, because 3.60 mole of chlorine will react with 3.60 mole of C2H6, and then some excess of this C2H6 will be remaining in the solution, and when all the chlorine is consumed the reaction will stop. And as we know that the reactant which is completely consumed first is the limiting reagent, that means the limiting reagent here is chlorine, and the product which will be produced is equal to the number of mole of the limiting reagent here, because 1 mole of the limiting reagent will produce 1 mole of the product, that means 3.6 mole of chlorine will produce 3.6 mole of C2H5Cl. So now we know the number of mole of C2H5Cl being produced, and from here we can find out the mass of C2H5Cl produced, which is very easy, as you know that mass is equal to number of moles times molar mass, and the number of moles we have found here is 3.60. That means the mass of C2H5Cl produced will be 3.60 mole times the molar mass of C2H5Cl, which is 64.51 gram per mole. And from here, this value will give us 232 gram. So this is the mass of the C2H5Cl, which will be found or in this reaction um, by reacting 125 gram of C2H6 with 255 gram of chlorine will give us 232 gram of C2H5Cl. Now in our question B, we have to find out the percent yield of C2H5Cl produced, and that is simply um, the actual yield, which is this over, oh no, so this is our theoretical yield. So our actual yield is given as 206 gram. 206 gram is being produced in this actual reaction. That means our percent yield will be the actual yield, which is 206 gram over our theoretical yield, which we have found from the calculations, which is 232 gram times 100%, and it will give us a value of 88.79%. So this is the percent yield of C2H5Cl produced if 206 gram of the actual yield is found in the reaction.